Hello and welcome to video number 10 of the EDS education program. In this video we are going to talk about several subjects. The EDS chart screen in general, single variable charts, histograms, multivariate detector charts, heat map charts, and cross-model charts. Let's start with the model charts. These charts are related to a single model. Activate the model charts screen by going into the model panel's main screen and double-click on the charts icon. Note that the server-level chart, which displays charts based on data from several models, is activated from the server's main screen. This is the chart's main panel. It includes several parts. On the left-hand side of the panel there are 4 buttons. The refresh button makes the system display the currently selected chart. The stop button stops the processing of the current chart. It may be used in cases where the processing takes too long. The classify button enables the user to activate the classification window. For further details about classification, please watch the relevant tutorial. The PDF image button creates a PDF file from the currently displayed chart. On the right-hand side of the screen there are 3 tabs. The first is the Variable Selected tab. The second tab is for formatting the chart display. The third one is for different switches that can be used when creating a chart. The upper part of the panel enables the user to select which chart to display, and determine the time period in which data should be retried. The single variable chart enables the user to display a line chart, for up to 4 different variables for a selected time window. Select the variables from the left-hand tab and click the refresh button. A relevant line chart for the selected variables and a time frame will be displayed. At the same time the system displays a list of events which occurred during the selected time window. If you select one of the events and then refresh the chart, a new chart will be displayed. A vertical line appears on the timeline, indicating when this event occurred. The second type of chart is the density chart. This chart has 3 different lines. The red line displays the relative or absolute frequency of the records in the selected period. When using the default format, the red line displays the relative frequency of the data between 0 to 1. If the absolute switch is selected, this line displays the number of similar combinations that have been observed in the data. The blue line is the distance line. It shows how far each combination is from the most common recent event. Distance in this case is measured by norm. For details about the distance measurement, see the tutorial about measuring rare and common events. The green line is the topology line. It measures how good or bad each combination is in relation to water quality. This measurement is based on the topology of each single variable. Note that when the user triggers a rare event, the red line should be below the similarity threshold. The distance should be above the similarity threshold, and the topology should be below the topology threshold. The 3 corresponding thresholds are all located in the model's rare similarity detector. The dynamic noise chart displays a result of a proprietary algorithm used by the detector. This algorithm separately measures the noise levels of both quality variables and operational variables. The blue line shows the noise level of the quality variables. If this line goes above the threshold, which is indicated by the red line, an event is triggered. The red line is set by the dynamic noise detector. The green line shows the noise level in the operational variables. This measurement can't trigger an event. It is just an indication for the user to see any correlation between the quality variables and the operational variables. The next type of chart is the correlation chart. This chart enables the user to display a correlation chart between any 2 variables and for any time frame. Select the 2 variables from the list and click the refresh button. The histogram chart enables the user to display a histogram of variable values for any time period. Just select the variable and click on the refresh button. The relevant period will be the one selected in the upper top part of the panel. A similar histogram can be shown for similarity topology, distance, dynamic noise, and fixed value. The last chart shows the histogram of frequency for fixed values for a selected variable. This means defining the frequency of a 2-minute fixed value, a 3-minute fixed value, and so on. The events bar is displayed above each chart as a toolbar which indicates the events that happened in the chart's relevant time period. Events are displayed as squares. A normal square indicates a regular event. A standing square with a height that is bigger than its width indicates an event which includes a dynamic noise detector. A flat square with a height that is smaller than its width indicates an event that was closed by the system or the user. The color of the square indicates the event's severity. If the user hovers over the square with the mouse, further details about the events are displayed. The 2D and 3D frequency maps enable the user to view the frequency data using a visual mode. Select two variables from the list and click the refresh button. A contours map for the two relevant variables will be displayed. The color legend on the right-hand side of the chart provides the color's meanings in the log scale. If a 3D chart is selected, the data will be displayed using a 3D picture. This format provides an easy indication, in addition to the color, about where the rare and common combinations are located. The rock contour map enables the user to view common and rare rates of change for a specific variable within a given time window. The chart displayed on the screen shows the common change in the value of chlorine within a 5 to 30 minute time window. This chart shows that a change between 28.6 to -16.5 microsiemens units, within a 30-minute time window, is a common change that occurred many times in the past. However, a change of 50 microsiemens within this time window is rare, thus, such an occurrence should trigger an alarm. The last chart in the list of multi-dimension charts is a contour map, which shows the frequency of changes in the dynamic noise with respect to time. The vertical axis is the dynamic noise value. The horizontal axis is the time window. Once again, the legend on the right-hand side of the chart gives the reference of color to frequency. It can be seen that a change of 0.3 in the dynamic noise within a 5-minute time window is a common change. On the other hand, a change of 0.5 in the dynamic noise within a 20-minute window is a very rare situation. This chart may be used to assist in calibrating the dynamic noise detector. This ends video number 10. We hope to see you at video number 11.